Yes, Assalamu alaikum students. I hope you are fine, doing well in your studies and are following my lectures. This is one more lecture I want to deliver you. It is on vector calculus, lecture number 12. Vector calculus, lecture number 12, and in lecture number 11, you know, we are doing the applications of line integral. I am just focusing on some more problems because there is this demand from the students who have this syllabus in BTech engineering. They don't have to do the theorems and these definitions extra. They have only application part there in line integral, surface integral, and in other things. So I want to share more problems with you in this vector calculus. It is the application of line integrals, applications of on line integrals. This is line integral application we are doing. I have written here some problems. I will write some more after this. Let us have the solution of these problems. Solution to first, this is application of line integrals. We are doing this. I will read out this problem, first problem, which is, I think it is quite visible to you. It is evaluate the integral. You have to evaluate integral over the curve C. It is a line integral y square dx plus x square dy. We have to evaluate this line integral over this along the curve. Along curve is x plus y equal to 1 from points from 0 1 to 1 0. This is the problem that you have to find. Evaluate this integral. This is of course the line integral. You see, let us see what is our curve actually. It is a straight line. X plus y is equal to 1. If you write this straight line, its equation is like this. This is the equation of this line. X plus y is equal to 1. It will meet here at point 1 0, and here it is 0 1. And we have to find out, this is my C, we have to find out the line integral along this line x plus y is equal to 1. Let us see, our given integral is y square dx plus x square dy. So this means according to given integrand, if you go like this, because this is a problem which was asked in some MCQ type questions. There f was given. You have to only write the character of f, vector force. What is this? Is this vector force rotational or not? There was some objective type question, and there were some choices, and one of the choice there was perhaps the rotational. So I write this. This is the integrand. So what will be the corresponding this vector function? It will be like this. It is y square I plus x square j. Okay. So accordingly, this means your r will be I dx plus j dy. Now you have to find out integral C, line integral over our curve is a straight line. Curve is a straight line. C f dot dr we have to find out. Okay. So this means we are going to find out C. This is your now y square I plus x square j dot. No doubt you will reach again here, but I have separated the vector force. What will be the force? What will be the force there, and what is its character? We want to determine the character of this vector function. Well, this is your I dx plus j dy, and this obviously gives you the given integral, which is I dot I is 1. It is y square dx plus x square dy. This is your line integral C f dot dr. Now let me find out the along this curve what will be my corresponding requirement, like limit and so on. I shall rub this portion. Well, along, in fact I will name it this straight line curve C. Straight line is also a curve. Y is what? 1 minus x. Your y is 1 minus x. You can in fact evaluate it in terms of x or in terms of y. It is immaterial. If you evaluate in terms of y x, then you replace y by 1 minus x. If you want to evaluate it in terms of y, then you replace x by 1 minus y. Naturally for y you will get the limit for y is 0 to 1, and for x it is x from x is equal to 1 to 0. It is at your disposal. You can evaluate it with respect to x or evaluate it with respect to y. There is no hard and fast rule. So I am replacing y by 1 minus x. I find here dx. What is my dx? It is minus it is y dy is minus dx. Okay. So from first, if I name it first, so first implies that line integral C f dot dr is given by, I will write first C here, y square. I am replacing this by 1 minus x square dx as it is, then plus x square as it is, and for dy I am using minus dx. Therefore you need the limit for x, because you have converted it into x. You need now limit for x. In any way, this gives me, now here x is from, when you go to along this line, along this curve, x is varies from, x goes from x is 1 to x is equal to 0. It will be 1 to 0. So I can write here integral x going from 1 to 0. This is x coordinate. This is your x coordinate, 1 to 0. Okay. This is your 1 minus x square. This you can write plus, or you can directly integrate it, no problem. There is no need to expand. It is 1 minus x square dx, then it is minus integral x 1 to 0 x square ds. Now how we integrate this? Yes, it is 1 minus x raised power 2 plus 1 by 2 plus 1. Internal derivative of this is minus 1. You know the integral of ax plus b raised power n is ax plus b raised power n plus 1 by n plus 1. Derivative of ax plus b, that is a. Write that in the denominator. I am doing it that way. It is 1 minus x 2 plus 1 by 2 plus 1. Derivative of 1 minus x is minus 1. So write the limit from 1 to 0. Here you will write it is integral x square. It is x cube by 3 from 1 to 0. Let us see what is this now. It is minus 1 by 3. Give the upper limit 0. When you give the upper limit 0 to this, it is 1 raised power 3 minus, when you give the lower limit, 1 minus 1 is 0, then minus 1 by 3. Give the upper limit 0, lower limit 1, it is minus 1. So what is this now? It is your minus 1 by 3. This is minus 1 by 3. This is minus 1 by 3 into minus. It is plus 1 by 3. Yes, it is 0. it vanishes. So your integral of this along C vanishes. So this implies line integral along C of f force function dr is 0. This implies f is equal to, what is f? It was your y square I plus x square j is irrotational. It is irrotational. This was given there. Actually integral is this. You have f there. F is y square I plus x square j. What is the character of f? There are 4 choices. Out of 1 choice, one is the suitable choice, that it vanishes. Line integral vanishes. So it is an irrotational vector. It is a irrotational. F is irrotational. In any way, let me have the second one problem. I will write it. We have solution to second. What is second? I will write if it is not visible. It is find the circulation of f around the curve where f is given by e raised to power x sin yi plus e raised to power x cos y. It is also in plane geometry. E raised power x cos y j, where C is the rectangle. Where C is a rectangle whose vertices are given by, its vertices are 0, 0, 1, 0, 1 comma pi by 2 and 0 comma pi by 2. This is the problem. You have to find out the circulation. Here you have to find out what? Find circulation of f along C. I am writing this question again, so if it is not visible to you, lower lines may not be visible, so I am writing this question. You see what is the nature of this question? You have a rectangle. There is a rectangle that join is 0, 0. Let me take this O 0, 0. This obviously this will be your, let it be A 1, 0. This is rectangle goes this. This is the rectangle, and this point is given by, let it be B 1 pi by 2, and let it is C is 0 pi by 2. Well, this is a rectangle OABC. Given vertices are 0, 0, 1, 0, 1 pi by 2 and 0 pi by 2. So rectangle is my required curve, given curve. So it is divided into 4 parts. Actually you have to find the line integral from O to A, then the line integral from A to B, then line integral from B to C, then C to O. It is, we have to go this way. Always go anti-clockwise direction, because when you walk on the edges of the curve should remain, the part of the curve hollow, I mean to say in layman's language, should remain on your left side. You walk here, it remains on your left side. So this is the closed path, positive path. So we go this way, OA, AB, BC and CO. We want to find out, this is my curve now, C. We want to find out line integral along this. Now you see, So far as this line is concerned, I need this equation. It is equation is, obviously it is x-axis, it is equation is y is equal to 0. It is a x-axis, so it is equation. This is y-axis. It is equation will be what? X is equal to 0. Now what is the equation of this? It is parallel to what? Y-axis at a distance of 1 unit. So it is equation is x is equal to 1. Parallel to y-axis at a distance of from this to this, it is 1 unit. So it is equation is x is equal to 1. Again, this is parallel to x-axis, but distance is pi by 2. So it is equation will be y is equal, x is equal to, sorry, yes, it is y is equal to pi by 2. Okay. So along OA I have y0. So along AB I have x1. When I go along BC I have y pi by 2, because it is parallel to x-axis at a distance of pi by 2. So it is equation is y is equal to pi by 2. Well, and along CO I have x is equal to 0. Accordingly we find out this circulation of this given force along the rectangle, while rectangle is bounded by these curves O, A, B, C. It is given the vertices. Vertices are given. Sometimes you have to find out I will next give you one more question, how you solve such questions. Okay, we are given here the given rectangle is OABC. It is the curve. This will be now curve. Now circulation, what is circulation of F? Around. It is actually the word correct, around OABC. That is around the curve C. It is line integral around the curve C, F dot dr. Well, you will write it as usual. It is C. What is your F? E raised to power x sine y I plus e raised power x cos y j dot, take it as dot is your, it is I dx plus j dy. This gives you curve C is now, it is e raised power x sine y, e raised power x sine y dx plus, is it both sides e raised power? Okay, it is e raised power x cos y, e raised power x cos y, e raised power x cos y dy. Name this first. Now this curve C is divided into 4 parts. It is actually OABC. We have to go along OA. We'll find out separately this. Now you see on OA we have y is equal to 0, y is 0, equation is y 0. This implies dy is 0. Then on AB we have x is equal to 1, implies dx is also 0. Then you go to BC. You have y is equal to pi by 2, implies that your dy is 0. Then you have along CA you have x0, implies dx is 0. Now you have to split this into 4 parts. I don't need now this figure. I shall rub it. So accordingly, we have the line integral of f along the curve C, which is a rectangle, dot dr is what? Where my f is this, it is divided into 4 parts. One is my, I will write here on OA. Now look here on OA, I have to put y0. It is e raised power x, y is 0, sine 0. It is dx as it is. Then plus, it is e raised power x, cos 0, y is 0. But dy is also 0, so this will not survive here. Then plus another part you have OA. Then I will go along AB. This is the another part, OA to AB. You have x1 dx is 0. x1, it is e sine y, but dx is 0, so this is 0. It is e plus e raised power 1, cos y is here, dx is 0. You will write here dy as it is. This is the second part. Then we will go to third part, plus integral. You have another BC. Along BC what happens? Y is pi by 2, dy is 0. It is e raised power x, sine pi by 2. Dx is as it is, dx I will write. Then plus here e raised power x, cos pi by 2, it is 0, but dy it is 0. This will not survive here. And last integral is this along CA. What happens along CA? Along CA, x is 0, dx is 0, so this will not survive. It is 0 plus e raised power x, it is e raised power 0, cos y, dy as it is, because our dx vanishes. Okay, well, this I have to now evaluate. Now I may require a rectangle again here, so for that I will just write this. It was your 0 0, it was your 1 0, it was your 1 pi by 2, OAB, it was your 1 0 1 pi by 2, it is 0 pi by 2, it was 0 pi by 2. Now you have to take OA. Along OA, this term does not survive. We have dx. We have to see along OA what is x. X varies from 0 to 1 along OA. So you will write this integral as x running from 0 to 1. This is your only e raised power x dx. But sine 0 is 0. It will not survive here because sine 0 is 0. It is simply a 0 here, then plus. Now you go along AB. This is not surviving here. dy is here along AB. Along AB I have to take y from 0 to pi by 2. It is along AB, y is from 0 to pi by 2. Write the remaining term. It is e cos y dy. It is e cos y dy. Then come to this BC. BC, you have dx there. When it is dx along BC, you have to see what is x. X is from 1 to 0. X runs from 1 to 0. It is sine pi by 2. You know sine pi by 2 is 1. It is only e raised power x dx. Then come along CO. In CO, this will not survive. You have dy. In CO, y varies from, in CO, y is varying from pi by 2 to 0. Pi by 2 to 0 along CO, pi by 2 to 0. And cos y, it is e raised power 0 is 1. This is cos y dy. I hope you have understood this concept. Let us now see what happens in further bit. Well, this we are finding out f dot dr, line integral along the curve C, where curve C is our rectangle. It is e, integral of cos, it is sine y. Y is from 0 to pi by 2. Then it is e raised power x from 1 to 0. Then you have integral of cos y, it is sine y. Y is from pi by 2 to 0. Give the limits. It is e sine pi by 2, it is 1 minus 0. This is plus e raised power 0 minus e raised power 1. This is sine 0 is 0 minus sine pi by 2. Well, it is e. This is your plus 1 minus e. This is also minus 1. And this is 0. This vanishes. It is 0. What does this mean? Yes, it also vanishes. This also means here, when you have the line integral over C, f dot dr is 0. This implies your f is irrotational. It is irrotational. Okay. Well, I will write one more this example here. Let me give you one more example here. I will write one more example. It is one more application. Evaluate in line integral C of f dr, where f is given by x square plus y square I minus 2xy j. The curve C is again rectangle, in xy plane. It is rectangle in xy plane, bounded by y0, xa, yb, y0. Its answer should be minus 2ab square. It is not irrotational, don't get confused. This is the problem. You see, when you have the position of this rectangle, it is in xy plane. This is your rectangle. It is your y0. This is the equation y0. Then you have xa. This will be the equation x is equal to a parallel to y-axis. So naturally this is point 0, 0. This will be your a0. Now he says x is a equation, yb, it is equation is y equal to b, and it is equation is one is x0, it is x0, y0, it is equation is x is equal to 0. This is equation y x-axis, y0, it is the equation of x-axis, x0. So this point will be here, this point, I mean this point, it is b0, b0. This is ab. So when y is 0, this is straight line, xa, this is straight line, yb, this equation parallel to x-axis at a distance of b from this. So this will be b0, this is 0, 0, a0, ab. You can find out this along curve, this. Similarly, you can do it now. Try it and do. By previous method you can go. You have the equation. Here you have dy is equal to 0 as previously. Then you will use in this curve. It is your f is equal to x square plus y square I. It is minus 2 xyj. You have to find out the position of this answer is you will get the answer. I will write the answer. When you find out integral c f dot dr, you should get it minus 2ab square. You will do this problem as we did previously. In the previous question, we were given the vertices of the rectangle. This vertex was given, this was given, this was given, this was given. And what is the difference? Here we are given the equations of the sides. Equations of the sides of the rectangle. This is x is equal to 0. This is x is equal to a. This is y is equal to b. This is y equal to 0. This will be y0. This will be x0. It is equation is x0. It is this. This is xa. It is yb. Naturally, this will be ab. This will be a0. This will be. This is. I'm sorry here. It is 0b because x coordinate is here 0. It is 0b. This is a0. It is 0b. It is ab. Now you can do it because on this y-axis you have x coordinate 0. Distance from this to this is b. Okay, and so equation of this is y is equal to b. So therefore you can do it like we did the previous question. So you can find out the line integral f dot dr. Its answer should be minus 2 ab square. I hope you have got the idea how to find out the circulation along the rectangle, circulation similarly along the triangle, circulation along the straight line. All these are the line integrals. Whether you want to find out the work done by the force, it is the line integral what we do. Whether you want to find out the circulation along by the of this vector around the curve. In all the cases we have tackled these problems. Now next I will I may touch one more problem or one or two problems where you can evaluate the line integral if you want to evaluate it along involving only dx. You want to evaluate it involving only dy. You want to evaluate it involving both dx and dy, so that you will get an idea now how to evaluate this line integral in general. Immaterial of the question whether you are it represents a circulation or it represents the work done by the force. I may touch one or more problems so that you are in a position to do all the problems on this this line integral from different books, maybe from your engineering books or maybe from your BSc mathematics books where you have the vector integration.